In this video, I'm going to be showing you how to find the roots of f of x. So we're first going to start by taking the last coefficient and we're going to find all the factors of -6. So it's going to be plus or minus 6 or plus or minus 1, and then it could also be plus or minus 2 and plus or minus 3. Next, we're going to take all those numbers and we're going to put them over the factors of the first coefficient, which will be the same. So it'll be plus or minus 6, plus or minus 1, plus or minus 2, and plus or minus 3. So here we have all the possible combinations for the roots of f of x. So what we do is we would divide. So then we would say one of the possible roots would be plus or minus 6. So you would do plus 6 over plus 1, for example, and that'd get you 6. Or you could do the opposite and so on. So we would end up with getting all of these as the possible roots. So we'd get plus or minus 6, plus or minus 1, plus or minus 2, plus or minus 3. And then we would go on to the fraction. So we'd get plus or minus 1 over 6, or we'd get plus or minus 2 over 6, which is also 1/3, which could also be combined for this. So plus or minus 1 over 3, or it could be plus or minus 1 over 2. And finally, plus or minus 2 over 3, or plus or minus 3 over 2. So right here is where we have all the possible roots for f of x. So now we have all the possible roots for f of x. So then we're going to go through and test to see which ones, when we plug it in for x, come out to 0. That means it's a factor or a root. So we're going to start off by using a simple number like f of 1. So when we plug in f of 1, we're going to see it's going to be -6 times 1 to the 6th minus 11 times 1 to the 5th plus 22 times 1 to the 4th plus 1 to the 3rd, and then minus 6x, or 6, -6 times 1 squared. So after we figure that out, we would do the multiplication. This is going to be -6 because 1 to the 6th is 1 to the 6th is 1 times -6 is -6, and so on. So it'd be minus 11, then it'd be plus 22, then it'd be plus 1, and then finally minus 6. So once we're there, we could see that -6 minus 11 is -17. Then minus 6 too would be -23, plus we got 22 and 1, which would be positive 23. So therefore, this all would come out to 0. So now that we see that f of 1 is a factor of f of x, because the remainder, or once you plug it in for x, it comes out to 0, we'd start with our synthetic division, which we would set up by first putting our factor 1 outside of the this half box here. Then we put the leading coefficient of each x or value that's a part of our equation. So we start with -6, -11, then 22, 1, and then finally -6. So I'm getting these numbers from the first term. So these first terms we use, and this would really be a 1. So then we put it there. So next, what we do is we'd start our synthetic division. So we drop this -6 down, and then you would multiply these two terms. So 1 times -6 is going to be -6. Then what you do is you add these two terms. So that's going to be -17 after you add those. Then 1 times negative 17 would be, again, negative 17 plus 22 would equal 5. Then 1 times 5 is 5. 5 plus 1 is 6. 1 times 6 is 6. So then you would add those and come out to 0, which is what we'd expect because 1 is a factor. So once we have this, we'd move on to our next step of finding another root. So these new numbers that we have here will become the leading coefficient of our new equation. So we're going to have f of x is going to be equal to negative 6x to the 5th, because what we did is we eliminated a term in the previous equation. So this was originally to the 6th. So then after we did synthetic division, we reduced it down, so now it's only to the 5th term. So now we have negative 6x to the 5th minus 17x to the 4th plus 5x to the 3rd, and finally plus 6x squared. So now that we have our equation, we would do the same for what we did the previous equation. So we plug in these terms to see which ones come out to equal to 0. So we would go through the list starting with the smallest and then working our way up to the more complex roots. And we would see that 1 wouldn't work, plus 1 wouldn't work, minus 1 wouldn't work, plus 2 wouldn't work, minus 2 wouldn't work, plus 3 wouldn't work, but we'd see that f of negative 3 actually works, because when we plug it in, we have negative 6 times negative 3 to the 5th minus 17 times negative 3 to the 4th plus 5 times negative 3 to the 3rd, and then finally plus 6x, or plus 6x times negative 3 squared. So when we multiply this out, we would get 1,458 is equal to negative 6 times negative 3 to the 5th. Then it'd be minus 130, or 1,377, which is equal to that. Then minus 135. Then finally plus 54. When you add all these numbers up, it comes out to 0. So now that we've seen that f of negative 3 is a factor because it, when plugged into f of x, our new f of x, it comes out to 0, we will again go with our synthetic divisions. We'll put negative 3, and then using the terms in our equation, so negative 6, negative 17, 5, and finally 6. So we would go through again. We drop down the negative 6, and we'd multiply. Negative 3 times negative 6 is going to be 18. Then you add those together. It's going to equal to 1 times negative 3, so it's going to be negative 3. So add those together. 5 plus negative 3 is going to be 2. Then negative 3 times 2 is going to be negative 6, which is finally going to come out to 0. So then this is finally our new equation. We're going to do the same thing. We're going to set this equal to f of x, and we're going to use these as our new leading coefficients on our variable. So we'll get, first off, we'll get, we're going to lower this first power, because that's what the synthetic did. So that's going to be x to the 4th, then it's going to be just plus x to the 3rd, and then finally it's going to be plus 2x squared. Now, once we're here, we don't have to go through and plug in digits to find out the roots. We could simply find the roots by taking out an x squared out of this, which would leave us to get a normal quadratic function to the 2nd power. So it'd be, after we take out an x squared, it'd be negative 6x squared plus x, and then finally plus 2. And that's all going to be equal to 0. So as we continue to factor this, we'll get negative 3x, and then we'll have to get a 2x in order to make this work out. This is still equal to 0. And then plus 2, and then finally plus 1. So then once we're here, we could simply find the root. So this is going to be x is equal to 0 with a multiplicity of 2. And then when we set these equal to 0 and solve, we will get negative 1/2. And then you're going to divide. It's going to be equal to 2/3. So finally, the roots of f of x will be, we used 1 up in the previous, up in the our first step, so it's going to be 1. Then we used negative 3, and then finally we have 0, the multiplicity of 2, and then 2/3, and negative 1/2.